This video provides an introduction to Matlab's plotting capabilities. Matlab possesses the ability to create outstanding graphs. This can be extremely helpful when you're documenting the results of your analysis or your data reduction. You can customize almost everything about graphs in Matlab: the line styles, the symbols, and annotations and labels. Matlab makes it easy to create both 2- and 3-dimensional plots. It's also easy to create animations or movies in Matlab. These can allow you to visualize your mathematical functions as they change in time. Now, I won't try to introduce you to all of Matlab's capabilities in this video. My goal here is to give you a reasonably good background in creating 2-dimensional plots and cover the basics that I think most people use Matlab for. With this background, you should be able to use Matlab's documentation to figure out how to use most of Matlab's other graphical capabilities. The first thing I'll do is introduce the basics of plotting. I've already used the plot command in our previous video, but I'll give you a little more detail about it here. Next, I'll talk about some options for formatting the data that appear on your plots. You can change the line styles that are used to represent data, or add symbols to represent the data points, and grids to make it easier to read values from your plots. You'll want to annotate your plots to provide information about the plot. Putting multiple sets of data on a single plot is really useful. For example, plotting experimental data points along with the expected results is common. In the last video, I plotted the function y of t equals 3 times e to the minus t over 2 times cosine of 4 times t from 0 to 10 seconds. That was pretty easy to do, but there are some things that can end up being confusing. For example, a new figure window opened in order to display the figure. This doesn't always happen, and we need to talk a little bit about the figure windows that are created or used when the plot command is used. This section of the video talks about figure windows, creating them, and managing them. When I created the plot in our last video, I created an array of times using colon notation. So t equals, starting at 0, incrementing by 0.01, ending at 10. Then I created the function itself by typing y equals 3 times exp of negative t over 2 dot times cosine of 4 times t. To plot the values of y at the time point specified in t, I use the plot command, plot of t comma y. In the simplest form of the plot command, the first argument is a vector containing the points on the horizontal or x-axis, and the second argument contains the points on the vertical or y-axis. When I press the Enter key on my keyboard, the plot gets created in a figure window. If there aren't any open figure windows, the plot command creates one. If there are open figure windows, the plot command uses the currently active window, which is the last figure window that was used. Now I'll create another function and plot it. The new function is z equals 5 times t dot times exp of negative t. Uses the same time vector I used before. Now if I plot z by typing plot t comma z, I do get a plot of our new function, but my old plot's lost. Matlab's plot command uses the currently active figure window, the one I created with my last plot command, to put the new plot in. If I want to create a separate figure window for my second plot, I can use the figure command. To create the new figure window, I type figure and press the Enter key on my keyboard. This opens a new figure window. Notice that this is figure number 2, as you can see in the title bar. Matlab numbers figures consecutively, unless you tell it to do otherwise. The new figure is the active figure window, so to plot the original function, I type plot t comma y and press Enter. Now I have 2 figure windows, each of which shows one of the functions I wanted to plot. I can create a figure with a particular number with the figure command by placing the figure number in parentheses after the figure command. For example, if I type figure of 5, a new figure window is opened named figure 5. This is now the active figure. I'll plot one of our original functions in this figure by typing plot t comma y. The contents of the active figure window can be cleared with the clf command. Figure window number 5 is still there, but it's blank. To completely remove a particular figure window, the command is close. Just type close with the figure window you want to remove in parentheses. For example, close of 5 deletes window 5. The window is gone. Close by itself with no arguments closes the active figure window. Close all deletes all the figure windows. So far, I've let Matlab choose how the data on the plot is presented. Usually, I want to specify the type of line that Matlab uses to represent my data. Now I'll talk about some simple options for changing the way the plot's represented. The three most basic options are the line type, the line color, and the symbol to display the data points. These can be specified as a string in the plot command. Strings in Matlab are specified within single quotes. For example, if I want to change figure 1 to a red dotted line, first I'll make sure that figure 1 is active by typing figure of 1 at the command window and pressing enter. Now I'll type plot of t, z, single quote, r, colon, close single quotes, close parentheses. R is the code for red, and a colon is the code for a dotted line. If I decide to change the appearance of the data points along the line, I can add an additional letter to the command. For example, to put circles at the data points, I can use a lowercase o after the symbol representing the line appearance. So I type plot of t, z, quote, r, colon, o, quote, close parentheses. Now I've got little circles at all the points in the arrays sent to the plot command. To see a list of all the available options, type doc space line spec. The help page shows line specifiers, marker specifiers, and color specifiers. Getting the data on the plot is just half the battle. If the plot's going to make sense, it usually needs to be annotated to include labels that tell what the horizontal and vertical axes correspond to. If nothing else, we need to know the units that are associated with the axes. In this section, I'll talk a bit about annotating plots. The command to add a label to the horizontal axis is xlabel. To use this, type xlabel and open parentheses, a string that you want to be displayed, and a close parentheses. To label the horizontal axis of our current figure as time in seconds, for example, type xlabel of, quote, time, comma, sec, in quote, close parentheses, and press enter. The corresponding command to label the vertical axis is ylabel. Let's label our vertical axis as z. Type ylabel of z. A title can be put at the top of any figure with the title command. The function for the current figure was z equals t times e to the minus t. To put a descriptive title, I'll type title of, quote, t times exp of minus t, end quote, close parentheses. Now let's talk about putting more than one set of data on a single plot. This is an important capability. For example, it's common to compare a set of data with a mathematical model of the data by putting the two on the same figure. We've already seen that if we just apply the plot function a second time to the same active figure, the data gets replaced. However, there are a couple of easy ways to get multiple sets of data on the same plot. One way to create a figure with multiple lines on it is to start with an existing figure. Normally, if I try to add another plot to this figure, I lose the previous plot. But there's a hold command that keeps the previous data and adds new data to the plot. I'll show you an example of this with figure 2. To make sure figure 2 is my active figure, I'll type figure of 2 at the command prompt. To hold this figure, I type hold on at the command prompt. Now, if I use the plot command again, the previous version of the figure will be retained and the new plot added to it. For example, I'll type plot of t, z at the command prompt. Now we have both sets of data, y and z, on the same plot. To release the figure, type hold off. Now if I plot some data on the figure, the previous version's lost. For example, I'll type plot t, comma, y to get my earlier figure back. If you plan ahead a bit, though, you can do the same process without using the hold command. Just add successive sets of data within the same plot command. To illustrate this, I'll first clear the current figure by typing CLF. Now I'll type plot of t, comma, y, quote, k dash to get a solid black line, comma, t, comma, z, quote, r colon to get an r dashed line for the z data. If there is more than one line on a plot, it's probably a good idea to add a legend to the plot so that we know what each set of data corresponds to. The command is legend followed by parentheses enclosing strings corresponding to the descriptions of each set of data on the plot. The strings in the parentheses are in the same order in which the data appears in the plot command. For example, type legend of first data set, comma, second data set. We get a legend on the figure with an example of the line style used to represent the data and a description of the data. These are probably the most common Matlab plotting options. In the next video, I'll talk about some slightly more advanced capabilities. I'll present capabilities for putting multiple plots in a single figure window, some additional line specification options, and setting limits on axes. I'll also talk about some additional options for text that you can annotate your plots with. Adding Greek letters, italicizing text, superscripts and subscripts, and converting numerical values to text that you can add to your figure labels.